as soon as I was finished talking about the code, it occurred to me that I probably didn't put enough emphasis on this idea of indexing. So that's what I want to do right now. And so, again, let's think about, we've got these two different loops. And the first loop loops over each one of the 948 players. And the second loop loops over the 9 different positions: pitcher, catcher, first base, etc. And so for each one of those 948 players, we have the likelihood function, hits per player, and the prior, which is theta per player. And then we loop over those 9 different positions, and we get the hyperpriors, the omega for position, the kappa for position, which is what we really want. And then we have to do this as an intermediate to take care of this, wanting to require everything to be positive. Okay, so what I really want to focus on, and I think the bit that's likely to be most confusing, is this line right here. The prior for the thetas. And so remember, each individual player is going to have its own theta that reflects the ability of that person to hit the ball. And so what's the prior for that? Well, here's the prior right here. And the hits for each individual player comes from a binomial distribution, parameters theta, and the number of times they hit at bat. What we're really concerned with is the parameter theta. So we're interested in the parameter theta per player, and it rises from this beta distribution, and this beta distribution has a modal value here that is going to influence the particular ability of the player to hit the ball. At least that's what we're assuming. We're assuming the possibility that the hitting ability of pitchers differs from catchers, differs from those who play on first base. So in terms of our omega, it's going to potentially vary with position, and we need to write the code to reflect that. And so if we think what we've got here, omega position player, let's just look at that. Let's look at omega position player. And think of what happens as we loop through, because it sits in this loop, we loop through these 948 values of player. And so the first thing we have is, first time through the loop, it goes omega position 1. That's going to give us some idea what theta is for player 1. But now let's look at this. Position for player 1. Let's look at our data. There's player 1, and there's the position. So effectively what we've got is omega 1, where position is equal to 1. But if we come back up here, we see that position is 1, then that's a pitcher. So the beta distribution from which we get the value of theta per player for player number 1 is going to have an omega, a modal value, the modal value of a pitcher. Now let's see what happens. We're looping through these 948 players. The next player we look at is player 2. So we look at player 2. We look at player 2. Well, what's their position? Their position is 7. That's omega 7. we come up here, what is omega 7? That is a left fielder. So if we think about the theta for the second player, the relevant omega is going to be the omega that's associated with 7, which is left field. And on it goes through each one of these 948 players. So this is just a little addendum to the previous part on code that hopefully will clarify this idea of, it's very tricky, double square bracket nested indexing.